All right, guys, welcome to your happy Friday. We are going to go over 6-4 compound inequalities. Just for a little bit of information about what's going on here, I'm clearly not here today. I'm making a video for you guys to still go over the lesson. The sub is to pause the video whenever you guys need to write down information or examples. You could pause it at any time, go back to anything. This video is also on my website if you need to see it again. After the video, there's a worksheet that the sub will hand out. You are to do it and have it ready by Monday. All right. Happy Friday. Hope you guys have a good weekend. Let's get started here. All right, today our goal is to learn to solve and graph the solutions to compound inequalities, right? So far, we've only been talking about regular inequalities. Now we're talking about compound inequalities, right? So what's a compound inequality? It's inequalities put together using the words and or, okay? And or the word or. So when we put those together, we get different types of, I guess you would say, cross sections, right? And we want to think the word intersection. If you think of a Venn diagram, if I want to graph the intersection of these two things, it's what they share in the middle, right? That would be the intersection. So when we think and, we want to think what do they have in common, or more specifically when we're talking about compound inequalities, we want to know what's the overlap, all right? And you'll see an example of that when we get a little bit further here, all right? So I'm going to just jump right into an example, all right? Here is an example of a compound inequality. The directions say to graph each and give the solution, okay? So this is what you do. It says y is less than or equal to 5 and y is less than 12. So here's what you do. Locate the smallest number, 5, graph it on your number line. There's my 5, okay? And now graph this inequality. Y is less than or equal to 5. So less than or equal to means I have a circle on 5, and it is filled in. And I graph things that are less than 5, okay? And then I also have to graph the other equation, or inequality. Y is less than 12. All right, so here's 12. That is my highest number. Notice I don't have anything in between. I don't really need anything in these spots here. All right, I just need my low number and my high number. The rest is assumed, okay? However, make sure that you get this right. If you have these two numbers mix matched, clearly you're going to be wrong. All right, so back to this graph. Y is less than 12. That is an open circle because it's less than. And again, I'm going to the left. All right. Now, look at how I drew my arrows. And think about what we talked about with the word and. Okay. The word and we want to think of as the overlap. All right. So let's look. Where do these graphs overlap? Well, my final solution, my final graph is going to have a shaded line on the graph. And I'm shading the overlap, okay? And the overlap here is everything that is less than 5, including 5. So if I want to write the solution for this using the word and, my solution is y is less than or equal to 5, because that's what the overlap is. That's what the word and tells us to do. All right, next example here. I have a is greater than 5. So I'm going to graph 5, and a is going to be greater than it, and that means I'm going to the right, okay? And a is less than or equal to 9. So here is 9. Again, no numbers in between, don't need them. Fill in my circle, and a is less than or equal to that, so I got my circle filled in for the equal to part, and my arrow is going to the left. Again, and means what is the overlap? And if you look, my overlap is in between the two, okay? It includes the number 9, but does not include the number 5. Okay, writing the solution for this. This represents what a can be, okay? A goes in the middle, a is in the middle. We're going to write a compound inequality in one statement without actually using the word and, okay? So look on the right-hand side of this here. If you look on the right-hand side, we can see that a and 9 are being compared. Well, I'm graphing things that are less than 9, so I'm going to have a less than symbol, but also including 9, so it's less than or equal to. Less than or equal to 9. And then look at the left-hand side of this. I'm graphing things that are greater than 5. So if we read this symbol from right to left with A in the middle, I'm graphing A is greater than 5. And that's how we write our final answer. Okay? All right, moving on here. If you need to pause at any time to go over any explanations, feel free to do so. Another right to inequalities using the word and is like this. If you see an inequality that looks just like this, it implies the word and. So this implies and. And if you look, that's exactly how we wrote our solution to the last problem. Okay? So this implies the word and we're going to graph it in the same exact way. So basically what we're doing here is the reverse of what we did last time. We were now taking this type of inequality and we're putting it on the number line. We're graphing it on the number line. All right, so here's how you do this. Okay, first take a look at 1/2 of the inequality. All right, so look what I boxed out here. I have -3 is less than or equal to h, or if you read it from right to left going this way, we have h is greater than or equal to -3. All right, so -3 is my low number, so I'm going to put that on the left-hand side, so -3 goes here. And I have to graph things that are greater than it, so greater than or equal to it. So I have a closed-in circle, and my number line goes to the right because I'm graphing things that are greater than it. Now I'm going to look at the right-hand side of the graph. I have h is less than or equal to 5. Okay, 5 we'll put up here, and less than or equal to symbol, and the graph the same thing, less than or equal to. Okay, now look, where do I have the overlap of green and blue? My overlap is right in between. All right, and now this might be a little bit confusing. You're going to see this exact style on your worksheet too. It's going to ask you to write the solution to this. There is actually no simpler way to write the solution. This, what you have up on top, is actually your solution. So there might be questions where I just give you the graph, what you like what we just did, and you'll have to give me the solution to it, which is -3 less than or equal to h less than or equal to 5. Okay, there's no simpler way to write that, so that is just your solution, so don't be confused there. All right, let's move on to the next one. Again, graphing the left-hand side first. My -3 is my lowest number, my +12 is the highest number, so I have 3 and 12 there. Okay, and I have to graph, reading it from this direction, I have to graph k is greater than -3, so I'm going to do that, open circle to the right for greater, and I have to graph on the other one, k is less than 12, open circle this way, and now my solution is shaded on the number line like so. All right, so if you can see, I asked you guys to graph this way so that we could, in the beginning, when we were asked to graph things like x is less than 3, I asked you to graph in this method so that, let me show you the method that I'm talking about here. Open circle less than this way. Okay, I ask you to start graphing in this method so that when we add a compound inequality, we know that our answer is going to be the intersection. It's a lot easier to see when we do it this way. Okay, that is some other ways to graph inequalities. They can be a little bit more complicated though. All right, so take a look at some of the things that we have here. If we're looking at compound inequalities, we could actually do some simplification first before we actually have to solve. So if you notice, if you look at an inequality like the one that we have here, there is just a variable in the middle. If you look at this one, we have a variable and a number in the middle. So we actually have an operation in the middle. And we do this in exactly the same way. Okay? First, here are the steps. We're going to use the following steps here. The first thing we're going to do is solve the left-hand side. You can solve the right-hand side if you want to, but just pick a side. I usually pick the left-hand side. I don't know, maybe because I'm left-handed, whatever. All right, and we're just going to solve this equality like we normally would. So if it helps you, maybe just write it separately. -5 is less than x minus 4. And now solve this inequality. it's just what we've been doing in the previous sections. Add 4 to both sides, plus 4, and I get -1 is less than x. Okay, so this is one part of the inequality. Then we're going to go ahead and solve the right-hand side. So we take this piece, okay, and we do that. I'm sorry, show you the step here. Second step is to solve the right-hand side. So I guess I'll write that over here. It's x minus 4 is less than 2. All right, and then solving that, we have plus 4 plus 4. We have x is less than 6. Okay. Now we have two different inequalities here. All right. Again, x is being compared to different numbers here. So look at the first one. We have x. We have -1 and 6. So my low number is here. I'm going to have -1, and my high number is 6. I'm going to have that here. All right. I'm going to move this so that we can have a clear graph. So x is less than -6. Okay. This is the one we're comparing, and just graph one at a time. All right. Again, this is a comparison using and. Okay, this implies and again if there is no explicit way and you have a compound inequality here. All right, so I have x is less than, x is greater than -1, so that's an open circle and an arrow going to the right. And then I have x is less than -6, open circle, arrow going to the left. Again, my double shaded region, my shaded region is where the overlap is because we're talking about the word and. And I'm going to interpret my graph here now. All right. Again, these are the values that x is satisfied for. Well, I have 6 on the right-hand side, and everything that's graphed is less than that. Okay. I have -1 on the left-hand side, and everything graphed compared to x and 1. Well, x is greater than 1. So I have to write, in terms of looking at it from left to right, from right to left, I have to write x is greater than -1. And now I've already written my compound inequality. -1 is less than x, which is less than 6. That's the final solution. Okay, so the full set of steps are here, and that's our final answer. All right, so first off, we started by solving each side, left and right side, and then we graphed each of these on there and then interpreted our graph. All right. Okay, the word or, another example here. Actually, I forgot I had another example just like the one from before. Just so you can see another one. Again, left-hand side. I'm going to subtract 2 from both sides over here. -2, -2. So I got 5 is less than w. Okay. And then I have on the right-hand side this equation, w plus 2 is less than or equal to 11. And if I subtract 2 from both sides, -2, -2, I get w is less than or equal to 9. Okay, and these are the two things that I have to graph. And my lowest number is 5, so that's going to go here. My highest number is 9, that has to go here. All right, so graphing 5 is less than w, or w is greater than 5. Open circle, arrow going to the right, because w is greater than 5. And closed circle here, and arrow going to the left, because I'm graphing things less than. Again, shading in between to show the overlap. And then, again, interpreting my graph, okay? The stuff in the middle represents what w is, okay? And comparing w to 9, well, I'm graphing things that are less than or equal to it. Comparing w to 5, everything being graphed is greater than 5. Okay, so w is greater than 5, and that is my final answer here. Okay, talking about the word or. Okay, already 20 minutes in, 15 minutes in here. We can also use inequalities joining the word or. All right, we want to think that if we use the word or, we want to think that both inequalities are solutions. Okay, the solutions come from both inequalities. We also want to think union. So again, if we're talking about a Venn diagram type of situation, we talk about union. Again, this is everything from both things. All right, so we want to jump into an example here. I want to graph the solution set of each compound inequality and give the solution. So, okay. Taking a look at these. Again, we're going to start off really simple. All right, we got n is greater than 3 or n is less than or equal to 9. Okay, so again, graphing these, we're going to do them one at a time. I'm going to give myself some extra space. N is less than 3. Again, my lowest number is 3. My greatest number is 9, so those go on here. Okay, and I'm going to graph n is greater than 3. Open circle to the left. And then I'm going to graph n is less than or equal to 9. Now, we are using a different word in the middle here. We're using the word or, which means that stuff from this can be a solution and stuff from this can be a solution. All right? If you look, if you're using the word or, wherever you see a bar over the top is a solution. And if you notice, if I were to shade all of that, it would cover the entire number line. This means that the solution is all real numbers. And if you don't know yet, this is the symbol for all, this is a symbol for real numbers. Okay? All real numbers because either one of these can be a solution. All right, let's do the same thing here. 5 is less than or equal to t. So I'm going to put 5 here. That's my lowest number. 8 is here. And I'm going to graph 5 is less than or equal to t. Shaded circle and a line going to the left. And t is less than or equal to 8. So I have a shaded circle and everything going to the left again. Okay? Now check it out. My solution, again, comes from both inequalities. So I start shading and I get to here, yep, it's or. So I keep on going. And now I only have one part of my graph shaded. Okay? This is not shaded on the right-hand side. So if I'm talking about what the solutions are for t, the solutions for t are anything that is less than or equal to 8. That's my final solution, interpreting from the graph. Because all of these are solutions here, and continuing on, there are more solutions. Okay? All right, another one. 7 is less than or equal to g, and that's actually my high number this time, so that's going to go over here. 2 over here. Okay, so let's graph this one first. I got g is greater than or equal to 2. So I have an open circle that's filled in, and I'm graphing things that are greater than it, so I'm going to the right. And I have 7 is less than or equal to g. So actually g is greater than or equal to 7. So if I'm graphing that, I have a closed circle again. And again, I got a line going to the right. Okay, same scenario as before. If I shade in my solution, remember, if we're using or, it can come from both of them. Both inequalities are a solution. So my overall solution are things that are greater than or equal to 2. So that's what I write. G is greater than or equal to 2. That's my final solution. Okay, and again, we can do some more complicated solving with these. All right, and these are going to be the last couple of examples that we go through. We can do some preliminary solving, which are just like what we've been doing in the past, but now we have, one or we have 2 inequalities instead of just 1. All right. So take a look. We have negative 3h plus 4 is less than 19, or 7h minus 3 is greater than 18. So all you're going to do is start tackling one at a time. So we're going to look at this one first. So I got negative 3h plus 4 is less than 19. So the first thing I'm going to do is subtract 4 minus 4 from both sides. Okay, now I got negative 3h is less than 19 minus 4 gives me 15. And now I just got to divide both sides by negative 3. What do we do when we divide by a negative? We flip that symbol. So I got a greater than symbol now, and now I have h is greater than negative 5. This is one of my inequalities. Now I'm going to do the other side, remembering our word is or. So I'm just going to start solving from up here. I have to add 3 to both sides, plus 3 plus 3. Then I have 7h is greater than 21. And if I divide by 7, I get h is greater than 3. All right, now I have to graph both of these. My low number is negative 5, so that goes here. High number is 3. That goes here. And now graph one at a time. I'm graphing h is greater than -5. So that is an open circle and an arrow going to the right. I'm also graphing h is greater than 3. Open circle, arrow going to the right. Using the word or, that means either one of these can be a solution. So I start shading things that are solutions. One line is a solution, one line like I'm talking about here, and 2 lines is a solution if I were to continue this one. So that goes right through this guy. And now if I'm comparing my solutions, I have graphed things that are greater than -5. Not equal to, but greater. So my final solution is h is greater than -5. All right, one more example like this, and then we'll be done. All right, so take a look. I got 4k minus 7 is less than or equal to 25. So the first thing that I'm going to do is add 7 to both sides. Plus 7, plus 7. That gives me 4k is less than or equal to 32. If I divide by 4, I get k is less than or equal to 8. This is one of my solutions. Again, I'm using the word or. Okay, so simplifying this side, solving this inequality, I'm going to add 12 to both sides. Plus 12, plus 12, and I got -9k is greater than or equal to 42. Oh, I'm sorry, I did this wrong. Minus 12, minus 12. That's why I was pausing there for a second. It didn't look right. Minus 12, minus 12. So that gives me that my -9k is not equal to 42. Sorry, it's less than or equal to 18. Much better. Okay. Divide by -9, divide by -9, and I get k is greater than or equal to, sorry, switch that symbol. K is less than or equal to -2. So these are my 2 inequalities that I graph. -2 is my low number, 8 is my high number, and I have k is k is less than or equal to -2, so that is a open circle, closed circle, and I'm graphing things to the left, and I have k is less than or equal to 8, so that is a closed circle as well, and again, lines to the left. So if I start shading, when I'm using the word or, if there's one line, at least one line, I continue shading, and now I look at what I've shaded on my number line, and I've shaded everything that is less than or equal to 8. So my solution is k is less than or equal to 8. All right, again, you can go back and review any part of this video at any time that you want. Again, it'll be on my website. The sub is now to pass out the worksheet for you guys to work on. I encourage you to try to seek out Math Lab if you have questions during the day, and come back Monday with questions. Enjoy your weekend. Take care.